Hello everyone. In this video we are going to go over how to create the cumulative relative frequency table and how to interpret the values. We first want to start with the table with 4 columns. The first column is values, second is frequency, third is relative frequency, and the last column is cumulative relative frequency. We want to start our value column going from least to greatest. We see that the smallest value in our dataset is 1. There is no 2, so the next highest is 3. There is no 4, so the next highest is 5. Then 6. There's no 7, so the next highest is 8. Then the largest number appears to be 9. So frequency just represents the number of times our value appears in the data set. So we can just count this. So for the value 1, it appears 1, 2, 3, 4, 5 times. 3 appears 1, 2 times. 5 appears 1, 2, 3 times. 6 appears 1, 2, 3, 4, 5 times. 8 appears 1, 2, 3, 4, 4 times. And 9 appears 1 time. Relative frequency tells us the proportion of our dataset that is a specific value. So we can find this by dividing the frequency of a value by the total frequency. Let's create a row called total. So the total frequency is just the sum of the frequency column. So 5 plus 2 plus 3 plus 5 plus 4 plus 1 is 20. Thus, the relative frequency for the value 1 is just 5 over 20, which is 0.25. For 3, it's 2 over 20, which is 0.10. For 5, it's 3 over 20, which is 0.15. 6, it's 5 over 20, which is 0.25. 8, it's 4 over 20, which is just 0.20. Then 9, it's 1 over 20, which is 0.05. The cumulative relative frequency tells us the proportion of values that fall at or below a specific value. So we can find this by summing up the relative frequencies for a specific value and the values below it. Since we ordered our values column from least to greatest, this is pretty easy. Since 1 is our smallest value, the cumulative relative frequency is the same as the relative frequency, so 0.25. Then the cumulative relative frequency for 3 is just 0.25 plus 0.10, which is 0.35. For 5, it's 0.35 plus 0.15, which is 0.50. For 6, it's 0.5 plus 0.25, so it's 0.75. For 8, it's 0.75 plus 0.20, which is 0.95. Then finally for 9, it's 0.95 plus 0.05, which is 1. We know we did this correctly because the cumulative relative frequency for the largest value, 9, is 1. This means that the whole dataset has values that are less than or equal to 9, which makes sense. Okay, now that we found the cumulative relative frequencies, how do we interpret and understand the values? It can be helpful to turn these into percents and think of them as percentiles. So we can do this by multiplying by 100. So for the value 5, the percentile would be 50. An interpretation of this would be that 50% of our data is at or below 5, and 50% of our data is at or above 5. This should sound familiar. This is just the median. Similarly, for the value 1, it's the 25th percentile, which is just the first quartile. It's the 75th percentile, which is just the third quartile. So using the cumulative relative frequencies as percentiles, we can better understand how our data is distributed. Thank you all for watching, and if you enjoyed this video, make sure to subscribe.